Hey folks, welcome to DSS 2021 at the day two. We have an amazing session for you today planned ahead. It's basically focused on architecting resilient and geo-distributed stateful applications on top of VMware Tanzu. We also have Vinay from VMware who's going to be coming and speaking about this in today's session. So just for quick introductions, my name is Amey. I lead the field engineering team here at Yugabyte, essentially helping some of our customers with data pipelines and helping them migrating from legacy databases to modern databases, which is distributed SQL database like Yugabyte. And I've been previously doing this for like good amount of my life. So been with Pivotal and the New York Stock Exchange and FINRA for the most part. Vinay, do you want to quickly introduce yourselves?
Yes, thank you, Amey. Hey, all. I'm Vinay. I'm a peer of Amey on the VMware Tanzu side. So again, I run a team of like solutions engineers who are customer facing and very focused on the VMware Tanzu side of VMware. Again, I have a lot of history with modern applications as well as modern platforms from the Pivotal days, and then I used to do application consulting previous to that. So to begin, I want to talk about Kubernetes as a platform itself has gained a lot of steam in the last few years, and it is only becoming more and more popular in the Fortune 500. One of our most popular customers, as well as like use cases, has been T-Mobile. We've been working with them for the last few years. They've been using some of our initial Cloud Foundry-based platforms, and they've been now expanding a lot into Kubernetes for all their workloads to increase their agility. Amey, do you want to speak about the rest of them?
Yeah, absolutely. Thanks, Vinay. So, folks, we also see bigger giants like Walmart, who is actually the top 5 Fortune companies, who's also leveraging some of these newer technologies like Kubernetes. So, specifically for Walmart, who spoke at 2019 KubeCon, they talked about like how they've leveraged Kubernetes to modernize their edge computing applications in the store itself, so that they don't have to worry about network latency between the data centers and the end stores where consumers shop. Pretty great example of how to leverage containerized workloads in an edge location. We have also heard from Apple in KubeCon 2020 on how they leveraged Kubernetes to do compute management. That is essentially providing a containerized workload as a service to their developers so that they can essentially continue building with very high developer velocity and getting new services out quickly and easily. So Apple did a fantastic talk. You folks should go and watch it right here at this YouTube link. Vinay, next slide.
Yeah, so this is a report that VMware conducts every year. And the 2021 report showed what are the benefits that a lot of the organizations are gaining out of like using Kubernetes, right? I'm not going to go through every one of them, but the top three that you see is better resource utilization, the ability to allow application teams to be more agile, release software very quickly into production, and as well as day two operations like doing upgrades and maintenance and patching. The other thing that we also saw was the number of applications on Kubernetes going into production is slowly increasing from last year. So as you can see, from 59% to 65%. And we're also, the trend that we're seeing this year is that a lot of them are trying to move towards a multi-cloud strategy. So now a lot of them are moving, are deploying clusters and applications on not just on premises, but on multiple clouds as well.
That's right. And then, Vinay, as we have seen, right, when Kubernetes came into inception in 2015, a lot of stateless applications actually started leveraging Kubernetes, whether it's Spring Boot or Node.js applications. But in last few years, we have actually seen dozens of these stateful workloads, like system of record or system of reference kind of workloads and databases, really giving users an ability to run stateful workload on top of Kubernetes, and hence they're achieving like higher developer velocity and ease of management when it comes to running stateless applications and stateful applications as well. And this is what we have also embraced in Yugabyte. So that is, we started looking at Yugabyte started looking at Kubernetes, I would say around 2017 timeframe. So essentially looking at how exactly can we run conducive stateful workload on top of Kubernetes. What are the constructs and everything from that perspective. So we'll spend next few minutes talking about what does it really take us to run a database on Kubernetes and why run a database on Kubernetes for the first place itself. So with that, The first and the foremost thing that Kubernetes gives you that VM or a bare metal cannot give you is essentially better resource utilization. That is, it allows you to package the database style workloads in a way that you get more out of your compute and memory and the disk side of storage side of things, as opposed to running a bare metal or a virtual machine based system for your databases. And in this process, you can actually offer a private database as a service to your developers and architect so that they don't have to worry about how to string things together, how does a distributed SQL database work on the other end. So that's a perfect thing for Kubernetes. You obviously have to watch out for noisy neighbors. That is, if you're running a heavy duty distributed system, and right next to that, if you place a heavy duty messaging system like Kafka, your network's gonna be a bottleneck and a choke point. So you need to really figure out how to make sure that these workloads do not run in the same cluster, or if they do, how exactly you're handling the traffic patterns for your workloads or microservices. The second thing that Kubernetes offers is the platform agnostic nature. That is, you essentially treat it as infrastructure as a code without having to worry about underlying IaaSes, whether it's deployed on hypervisors or directly on bare metal. It doesn't matter to Kubernetes because it gives you a single control plane. And it basically is super portable in the sense that you can deploy your stateless and stateful microservices in one Kubernetes vendor, belong to one vendor. Same thing can be done in any other vendors, which is CNCF certified. There are a few challenges, though, when it comes to portability. That is, some cloud providers go an extra mile in proving them out in the sense like they have a specialized load balancer or a disk type that may not be available in the other cloud providers. So you have to pick and choose your poison when it comes to deploying and making sure that the constructs and everything is available in every single Kubernetes infrastructure that you're going to be deploying on. The third thing we look at is how does Kubernetes help you with automating some of the day two operations? And this is very important from a database standpoint. That is, when you stand up a database cluster, it's pretty easy to go get everything hooked up as a day one story. But day two, you need to make sure that it can scale up, scale down, do rolling upgrades without any downtime, or do periodic backups without hampering your workload. And this is exactly what Kubernetes provides you those constructs through custom resource definitions. So this was something that got added to Kubernetes at a later point, but you can now create custom resource definitions through a Kubernetes operator framework so that you can handle all of these day two automation scenarios easily. And it's very less onus and overhead to your operators to go and offer this as a service. But there are certain things that essentially a legacy database cannot handle. That is, legacy database were never handled to get this automation and embrace this whole cloud native nature from Kubernetes. So that is, if you take a legacy database, put it in a container and try to use some of the Kubernetes constructs, you leave a gap in there that there is a potential for a data loss. And that is where something that Yugabyte has brought to the table here. That is the innovation in the industry to use a distributed SQL database so that you can take advantage of all of these things is what Yugabyte basically helps you with. So a quick history of Yugabyte is that we created this company and created this product as well as company so that we can handle some of the toughest things in the database industry. That is, Yugabyte as an architecture and a single database platform provides you scale, resilience, and HA built into the entire architecture. It's not an afterthought. That is, you don't have to worry about replicating your data yourselves. It's completely handled by the Yugabyte cluster itself. And with that, we focus only on the transactional workloads. That is, any workload which needs a very specific SLA to your end customers and needs to scale up and scale down elastically, those are the best suited workloads for Yugabyte, where you have real-time consumer-facing applications. That's how customers use this for. And with that, since we're born in a cloud-native era, we ensure that the database itself has no platform lock-in. That is, can deploy on bare metals, virtual machines, or Kubernetes like containerized workloads easily without any code changes, without any issues. And net, it's 100% open source code. So you can go to GitHub, browse our entire code, download the compiler, download the compiled binaries, and start running it right away. Vinay, next slide. Yes. So when you take a look at Yugabyte, and let's say compare it to two other options, that is Postgres, which is a single node offering. You can deploy it on top of Kubernetes, but you have to manage your HA and resilience and everything by yourselves. That is, Postgres itself doesn't do any of these things. Versus what Yugabyte was inspired by is Google Spanner. That is, Google Spanner today powers most of Google's main revenue generating business, that is Google Ads and Google Maps and some parts of Gmail. And Google Spanner essentially was the first distributed, horizontally scalable distributed SQL database that was brought to the market. And they essentially launched it as Cloud Spanner back in 2017. So we were very inspired by Google Spanner and the paper that Google had written. And we ensured that Yugabyte is basically built those kind of mindset. That is, the lower half of the the lower half of Yugabyte is actually inspired by Google Spanner. That is, it's a distributed key to a document store that takes care of like providing you strong consistency and automatic rebalancing and sharding of data, and which is asset compliant. So it's on backs of Raft as a consensus algorithm and customized RocksDB as a storage engine. And then on top of that, to appeal to an existing developer market, we went with a Postgres compatible API for your relational workloads and a Cassandra compatible API for your non-relational or semi-relational workloads. So as a developer, you get best of the both worlds and still ensuring strong consistency and asset compliantness to your end applications with Yugabyte. Vinay, if you go to the next slide. Okay. You want to take it over?
Yep. So I wanted to talk to you all about like you've heard a lot from Amey about like what does it take to build a cloud native database, as well as like what does it mean to be a cloud in the cloud native database market. Now, what about the runtime aspect of things? So you're also thinking about like how do I roll this out? What is the container infrastructure? What are the things that are required, right? And when we look at the whole cloud native ecosystem, there are many concerns. Like it could be like the DevSecOps aspect of things, from a container registry, as well as observability. What is the actual container runtime? What are the different tool chains? So this is the entire ecosystem for cloud native. And that's where we as VMware Tanzu come into the picture. So the whole idea of VMware Tanzu is that you have the consumers on the right side who are expecting modern applications. These are the revenue generating applications there for a customer. And so what does it take, right? So from the left-hand side where you have the developer who is building their applications in any language and using any kind of CI, all kinds, microservices in different languages. So they would be developing code on their side. Now it takes a lot of a few processes to move this code into production. And it starts off with the dev aspect where you're automating, building containers, as well as like using the latest secure open source images for any other software that you want to consume. Then you have an appropriate CI/CD system where you have a private container registry where you store all your container images, whether you're building it or you're consuming it. And from a day-to operations side, you're going to need a single control plane to manage your Kubernetes-based, open source Kubernetes-based clusters, whether it is on premises or in the cloud, whether it is a Tanzu Kubernetes cluster or whether it is any other Kubernetes cluster provided by a cloud provider. You want to do all of these without sacrificing some common concerns like observability, having the ability to connect your workloads across multiple namespaces, and last but not the least, security, because without security, again, none of this actually makes a lot of sense, especially with all the cyber attacks that you constantly see today in the market. Now, if I'm not going to speak about the dev aspect of things, but one of the things that we're seeing a lot more, as we talked about in the State of Kubernetes report, is we're all moving to the multi-Kubernetes cluster kind of format, which means that you're going to have a single organization who are going to have many clusters, and it could be divided based on development testing, or it could be divided based on BUs. Now, when you have a multiple cluster kind of a operating environment, you're going to need a single control plane to manage policies, to backup and restore across all these different clusters. And not just that, we are also going to need some kind of a common observability platform that can look at not just parts of your stack, but an end-to-end end-to-end visibility, all the way from the applications down to the infrastructure, down to the clusters and the infrastructure itself, so that when things go wrong, you're able to pinpoint where exactly are the issues. I'll just give you a quick overview of what that kind of looks like. If you look at Tanzu Mission Control today, which is the control plane, there are many concepts over here, like you can group clusters, whether you can actually create your own Tanzu Kubernetes cluster, or you can attach any conformant Kubernetes cluster. So for this example, obviously, I just have one single cluster deployed on top of Amazon with Kubernetes version 1.20. If you go inside the specific cluster, you can see what's deployed, like how many resources are available, what are the different agents that are deployed, all the different nodes, the namespaces, some of the workloads that are deployed on this specific cluster. And one important thing over here is like we build integrations to observability and other SaaS solutions that we have directly over here. So you don't have to think about, I need to provision a cluster, I then need to like figure out how to do observability as part of this cluster. All of these things come built in as when you use Tanzu. Now let me just go back.
Perfect. So Vinay, that's pretty good. And really, Tanzu team has taken a lot of inputs from the community to make sure that, you give a single console for observability and manageability so that users don't have to go to every single cloud IaaS platform and their stack driver equivalents or CloudWatch equivalents to go and look at the metrics. So that's really great. So folks, why don't we do this? Let's take a look at how can we go and deploy Yugabyte on top of Tanzu. And essentially for this, Yugabyte has created a product called Yugabyte Platform. So essentially, Yugabyte Platform are those set of key learnings, like in terms of database reliability engineering practices that our founding team had learned over time in Facebook while they were operating massive HBases and Cassandra clusters at scale. And Yugabyte Platform provides you that one single management console to go deploy Yugabyte on top of any IaaS or any Kubernetes of your choice. So with that, what happens is, as a user, you first deploy Yugabyte Platform on top of your, let's say, Tanzu in this example, and then you can go and launch any number of Yugabyte clusters that you want, dynamically scale up, scale down, hence getting best of both worlds. That is, Tanzu, which is platform agnostic, can be deployed on any cloud provider, and then Yugabyte running on top of Tanzu to provide you that elastic, stateful database as a service. So with that, Vinay, can I take a quick few minutes and show our team today on how you can do Tanzu, Yugabyte on Tanzu? So folks, as I mentioned, this is how Yugabyte platform looks like. We've already, just for this demo, we have already deployed on top of a Tanzu cluster that Vinay just showed you on the Tanzu mission control. For the first time, when you log in as an admin, you basically get a choice of giving this any type of Kubernetes or VMs through IaaS or even on-prem bare metal systems that you want to deploy Yugabyte on top of. For this demo, we have specifically deployed this on top of Tanzu. So you can go and give Yugabyte platform your Tanzu config. Remember that Yugabyte platform itself runs on this Tanzu, so you're not sharing any data with any of the Yugabyte SRE teams directly. This all remains in your Tanzu cluster and its boundaries that way. Now, as a developer, I can now go and say, I want to create a simple universe. And we call our clusters as universes because they span multiple regions. So let's say I can do something like DSS 21. I can select a Tanzu provider that Vinay has configured it as YB-config, select the region that is pre-configured, and then select the form factor of machines that are in there so that you can go and deploy a X number of pods in the Yugabyte cluster that you want. So you can just select that from a small or extra large, depending on the t-shirt sizing you have done for your use case. Obviously, security is built into the product from day one. That is, you can do node-to-node TLS or client-to-node TLS, or you can do an enable encryption at rest, just click of a button. So for today's demo, we've actually created a cluster for you. That is, this is specifically a 6-pod cluster out of which there are 3 pods running a master and 3 pods running tablet server in Yugabyte, which are storing data and doing a read-write operation as we speak. So as you can see, Yugabyte platform gives you a quick snapshot into like what exactly is happening into the cluster. You can go drill deep into what kind of workloads you're running. Take a look at like, how those metrics, how those workloads are performing. It's very easy for you to go and scale up this cluster. So let's say I can just click on Edit Universe, add new pods, and click Save. This is going to take care of rebalancing and resharding the data, and it's a no downtime operation for your end consumers. So that is, your applications can continue to read and write data into Yugabyte without having to worry about how your cluster is getting scaled up or scaled down. And the same thing applies for rolling upgrades without any downtime. That is completely built into Yugabyte through this mechanism of consuming Kubernetes constructs like stateful sets and Helm charts and Kubernetes operator-based deployments itself. Now, that's one of the main things that we have basically achieved to give you a handle as a user in terms of making sure that you can run Yugabyte as a service in your Kubernetes space, whether it's Tanzu or Tanzu running on AWS or GCP. It really doesn't matter to us or matters to you. Now, that being said, let's take a look at a real life example of how you can leverage Yugabyte when it comes to transactional database, leverage Tanzu when it comes to having a platform agnostic Kubernetes solution which can run on top of any IaaS, and using some of the core technologies out there, that is Spring framework, which basically is one of the best, it's proven the best way to write enterprise microservices because it just eases out the way you go and deploy scalable microservices, and blending that with Yugabyte gives you best of the both world in terms of flexible cloud native microservices with a stateful backend as well. So we take Yugabyte, Spring, and React, our UI application, and deploy it on top of VMware Tanzu. And the application is very straightforward. That is, it's a microservices-based application that allows you to just go and buy things, let's say like a retail marketplace. So let's say for the first time when I load this application, it's going to pull in certain records. Obviously, all the data is stored in Yugabyte. It's rendered through React, and the backend application microservices are all Spring Boot in this case. And let's say I just look at a quick product here. I click on Add to Cart, go back to my home screen. Let's say I add second product, Add to Cart. I can go and do a transactional checkout. That is, I click on checkout. This order is completed, and the data goes back to Yugabyte. But when you just look under the covers on what exactly happened in this case, you can take a quick look at, since everything was running on Tanzu, it's all cloud native, your UI application actually hit an API gateway powered by Spring Boot. And depending on the activity that I was performing, whether I was looking at a single product, then it went and touched upon the Cassandra API of Yugabyte, so we call it YSQL, and fetching and rendering the data that was stored in Yugabyte cluster. The same thing when I performed a checkout or shopping cart kind of a microservice, it was using the relational database API of Yugabyte called YSQL. And at all times, it was asset compliant transaction across multiple different products that basically ended up in a checkout and shipping that order to the end customers. And anywhere you saw any ratings or reviews that were getting populated, that all comes through Spark, basically Spark leveraging that data from Yugabyte, computing that, and storing back the data as a serving layer again in the Yugabyte cluster. All of this is basically available for you folks to go deploy it yourselves on this GitHub link. So you can go and deploy it on top of your Tanzu environment and get a feel for like how easy it is for you to go and do this right away. Now with that, we definitely want to take a look at what would happen if one of this microservice is not performing well. How do you actually look at some of the metrics? And that's where Vinay, you can show us how to look at some of these things from Tanzu control.
Thanks, Amey. As we spoke before, right? So within Tanzu Mission Control, where you can look at all your different clusters, it provides an easy integration to a utility called Tanzu Observability. And it is a full stack observable solution. So right now I'm looking at a cluster view or a Kubernetes cluster view. I can choose the different namespaces that exist within this cluster. So for now, let's just look at the application that Amey was just showing us, right? So the application itself has 6 pods, and you can come to the specific namespace under default where it's deployed. You can see all the different CPU usage, the memory usage for each of these pods. You can also see a lot of more detailed information for each of these pods, like how much memory are they being used, et cetera, et cetera. So one of the good things of having a single observability platform, and also the fact that you're running your applications and your Yugabyte clusters on the same infrastructure, is you can go and switch to seeing how is Yugabyte performing itself. So underneath the covers, I can go to the YB dev namespace, and I can start to see, oh, now that we have 12 pods as part of the Yugabyte platform that's running. So now you can start to see how much CPU usage is being used by the Yugabyte pods themselves. You can see what the storage is for each of them. And you can also drill down a little bit more. Like you want to see other aspects of like, okay, how is the infrastructure itself doing, right? So the Kubernetes nodes. And if you need to scale up some of your Kubernetes nodes over here, so because there's a lot more data or there's a lot more usage happening, so a lot of these things can be done via this single control plane of Tanzu observability, as well as a combination of Tanzu mission control. It's your one-stop shop to manage both your data applications, your databases, as well as your Kubernetes infrastructure. And then finally, wrapping up. Amey, do you want to take this?
Absolutely, Vinay. So first of all, thanks for that demo, Vinay, because it helps us put a cloud native mindset in terms of like observing and managing that entire stack end to end. And folks, when you take a look at that demo, all of the components are scalable. That is, you can scale up your Tanzu environment, you can scale up your API gateways and Spring microservices, or scale up the Yugabyte platform itself without having any issues. So you can actually do 500,000 or a million writes per second in the same demo just by generating some more data in there. So now when we look at putting best of the both worlds together, that is taking Tanzu as essentially the spearhead when it comes to like running enterprise style microservices on top of Kubernetes, and taking Yugabyte, which provides you a stateful workload on top of Kubernetes, you can actually put this in a way that this combination allows you to run truly global, truly global cloud native applications. That is, you can take a single cluster of Yugabyte, which is spanning across different Tanzu environments, and whether those Tanzus are deployed on top of VMware, let's say on US West, or deployed on top of Google Cloud on US Central, or Azure on US East, it's one single Yugabyte cluster that is basically scalable and available to you as a highly available operational data tier. And this kind of combination prevents you from any disaster or a failure scenario. That is, you will have no downtime or a performance degradation when you end up losing one of the Tanzu clusters in this case. And it also allows you to meet some of your data residency and compliance requirements set forth by your IT InfoSec team to ensure that your data remains in those data center boundaries, even though Yugabyte is operating as a single cluster across all of these. So we encourage all of you folks to try out some of these things. Please reach out to me and Vinay even after this session for any questions. Both of us are available on Slack, and we're happy to take any questions at this point. Thank you.